First we start with server.py. Here the object-oriented programming is used and class server is initialized. We try to get server port number which is passed as argument while running the code. We use the socket AFINet which provides inter-process communication between processes and the initialization of the socket takes place. Then we use bind command to bind the particular port number to application. Then we listen to that request that comes from the client. We receive the client information address port through the RTSP TCP session. After that, the client accepts the request. Now we call the server worker.py where all the work of server takes place.
Now here we will see the working of the server worker file. Here we are importing the various libraries that we need to implement this file. In class server worker, we have four type of option. First is setup, which will establish the connection between the client and the server. Next is play, which will start sending the packets one by one to the client. Then we have pause, which will pause the packets and the video that is being sent to the client. Next is tear down, which will end the connection between the client and the server. There are four states in this. Init is the state when the connection is not established between the client and the server. Next is the ready state when the connection is established but the video is not being played. Next is the playing state when the video is being played on the client side. There are three types of return status. First is 200 OK when the packet is being successfully sent. Next is file not found when the movie file is not found on the server side. Next is connection error when connection establishment is not successful between the client and the server. Now this defines the constructor for the class. Then we are having threading on the server side. This receive RTSP request will receive the RTSP request from the client side and it will decode all the data that is received from the client. Now process RTSP request will split the request that we have got from the client side into various variables. The first we can distinguish is the file name, which is the name of the file that is being played on the client side. Next is sequence number, which is number of the frame being sent to the client by the server. Now we'll see the action that is being performed on getting the request from the client. First one, if the request is of setup, then the state is set to init state, and if the state is init state, that is if the connection is not being established and setup request is being played on the client side, then this function will be executed. Here the function will first try to find if the file name that is being passed as an argument on the client side is present on the server side. If it is present, then the state will be promoted to ready state, and if it is not present, then file not found error will be passed to the client side. Session ID will be assigned to the client side, which is a random number generated. Now on successful connection between the client and server, the server will send 200 OK status and the first sequence number to the client. Now in the client, as the server will store the RTP port number of the server as RTP port client info. The play request sent by the client. Current state of the server is ready, then the following will take place. The state will be updated to playing, and on successful updation of the state, it will return the 200 OK status to the client. Now let's talk about the pause. When the client will request for the pause, if the current state is playing, then it will update the state to ready and it will again reply with the successful status of 200 OK. Now, if the request type is of tear down, then it will end the connection between the server and the client and reply with 200 OK with the sequence number. The send RTP function sends RTP packet over UDP. If the client info event is set, then is pause or tear down, then it will break. If the request is of pause or tear down, then it will stop sending the packets. The make RTP function will make the packets that sent from server to the client. The reply RTSP will send the status of the actions taken to the client.
When we run the client launcher.py, the user needs to pass 4 command line arguments, which are as follows. First, server address, which in this case is local address 127 0.0.0.1 server port, client port, and the file name. It then sends this information to client.py.
Here in client.py file, we are importing libraries like Tincter, socket threading, and system for performing various operations. Also, we are declaring cache file name as cache and the file extension .jpg to store the cache as image files. Now we declare the class client and assign various state and operations for performing various things. Init function defines the constructor for the client.py. Here we have declared various variables which will be used further in the file. Now here we have create widget build the GUI of the application. We have start button, tear down button, pause button, setup, movie and all the other functionalities that are required in the application. Now listen RTP function will listen to the RTP packets data that is received from the server side. Then it will decode the data and the current frame number contains the frame number of the current packet that is received from the server side. If the current frame number is greater than the frame number that is received, then it will drop it as it could be the late packet that is arrived from the server due to various constraints. If the teardown is confirmed by the server, then it will close the connection between the server and the client and the GUI will exit. WriteFrame function will get the data that is received and it will cache it with the session ID and it will write the data into the cache. The update movie function will perform the GUI operations and it will update the image file from the cache. Connect to the server function will start a new RTSP TCP session and according to the server address and the server port provided in the argument. Now the function send RTSP request. If the request code is set up and the current state of the system is in it, then the new thread will be formed and setting the RTSP sequence number to 1. The request formed will be set up the file name of that is to be played, RTSP and the version, sequence number that is in this case 1, transport layer information and the client port. If the user presses the play button and the current state of the system is ready, then the system will start incrementing the sequence number by one and will send the request to the server in the following form. If the user presses the play button and the current state of the system is ready, then the system will start incrementing the sequence number by 1 and the request sent will consist of play, file name of the movie that is being played, RTSP and version number, sequence number, session ID of the user. Now the request code is pause and if the state is playing then the sequence number will increment by 1 and the request sent will be of pause, file name, version number, sequence number and the session ID information of the client. Now, if the request is tear down and the system state is not in it, that is, the setup has been already done, then the sequence number will increment by 1 and the tear down request will be sent to the server along with the file name, sequence number, session ID of the client. This will encode the request that is made in the client side. The receive RTSP reply function will receive RTSP reply from the server. If it receives any reply from the server, then it will pass it to the parse RTSP reply function after decoding. If the request sent is tear down, then it will shut down the socket and close the RTSP. Now here we have parse RTSP reply function which will parse the data received from the server as a reply. It will split the data in terms of sequence number and other details that is found as a reply from the server. If the sequence number is same as RTSP sequence number and if the session ID is 0 then it will assign the session ID to the variable. Now if the session ID of the client is same as the session ID received from the server as a reply and the status is 200 OK and the request made is of setup, then the RTP port will be opened and the request sent is of play, then the state will be changed to playing and if the request sent is pause then the state will be changed to ready, or else if request sent is of tear down then the state will be again set to the init which is the initial state before setting up the connection between the server and the client, and the tear down ACK will be done converted to 1. The open RTP port function will set up the new socket, and it will assign the state to ready, and it will bind the server port provided as an argument to the client which is currently running, and it will load, and if any error occurs then it will show warning as a form of GUI. The function handler is used to handle the events like user clicking on the cross button in the GUI to exit.
Now we will run the file server.py as follows: python server.py, and we are specifying the port number for the server. Now the server is running. Now in the another terminal we will run for the client. When we run the client, user needs to pass 4 command line arguments, which are as follows: one server address, which is in this case is local address 127.0.0.1, then the server port which we specified in the server terminal, then the client port and the video file. We need to set up the RTP client. We are getting the data sent and received. Then after play we are getting sequence numbers which are sent and received. Then after pause we can see that the current sequence number is 3 and session number is as follows. On server side we can see that the data received and sent. Play and pause requests are made on the server. Then after tear down we can see that tear down data is sent.